so for this lesson, we're going to do a computer simulation slash lab. So it's going to look like this when you get to it. The objective is going to be to accurately interpret and draw velocity and acceleration graphs. So what we did last lesson, right? You're going to go to this link. I'll give you guys a link that goes straight to it. This one that I have right now doesn't go straight to the moving man simulation. When you get there, you are going to investigate the moving man by dragging the dude around with your mouse. So what you're going to get, is this guy here. You can grab him. You can start to see that it graphs stuff that you're doing there. And just answer this question. So go through and answer number one. Number two, making predictions. Make a chart like the one below on your paper without using the moving man. So pretty much for this lab, what you're going to do is you're going to start off with a graph or a chart, something like this, right? And you're going to show me what you think that would look like. So in this scenario A, the man starts the tree and moves toward the house with constant velocity. So you're going to show me what the distance time graph looks like, the velocity time graph, and the acceleration time graph looks like for that scenario. And for number two here, I said make a chart like the one below on your own paper. I did, however, or you do, however, on the very last page, you have a bunch of these already kind of pre-made, so you don't have to really make your own. So you've got those. What I do want you to do, though, explain your reasoning for the graph's appearance. So you're going to make your own, right? And tell me why you think it would look that way. Then what you're going to do for number three, now use the moving man simulation to verify or correct your prediction or predicted graphs and reasoning with a different color pen. Be sure to use the sliders to enter yada yada yada. Yeah, so what I mean by that is if you try to move your guy around, you get really bumpy data, right? So instead what you're going to do, I'm going to just reset, yeah. What you're going to do is you can set your position beforehand with this arrow on the left. You can set it to, have an acceleration, let's say, positive acceleration like that. And then if you press play, now it'll actually, something like it would actually look like. So that's what you're going to do. Do the sliders first and then press play, and then you won't get all that really rough data. So number four says, I can't move down. One sec. There we go. Number four says make new charts like the ones above for each scenario A to H. Predict what you think the distance, velocity, and acceleration graphs will look like. So the same type of thing, but here's the different scenarios. So scenario A we already did, and then there's B, C, D, E, and F. So I want you to do those. And then G and H. Look at your graphs, reasonings, and the corrections from questions 2 to 5. Discuss with your group. Sorry if you're not in a group. If you're doing this by yourself, you won't be able to discuss it. And then write down your discussion. So maybe if you're by yourself, write down your thoughts, why some of your predictions were wrong, and how your ideas about motion have changed. So for this lab write-up, you need to have really these things. So title, data. So in this case, it's all the graphs with explanations, predictions in one color, and correct graph in another, and an answer to question 6. So just know that this is a Physics 20 lab, and you will be marked on the quality of your work, right? So if you just draw me, like on that next page, something like, this, and you don't explain anything about it, like why you think it's that way, then you're not going to get full marks for that. So just know that. I want detailed explanations for why you chose what you did, and even better if you show me, or you do it on the actual gizmo here, show me why, or tell me why you were wrong, or why it is different. Okay, so that's it. So go ahead and you can start that lab, and I'll see you guys in lesson 7.